Welcome to Westover Scientific's presentation of Inspect Before You Connect, and Introduction to Fiber Inspection and Cleaning. Westover is the industry's leading supplier of optical connector inspection equipment. For over 10 years, we've worked with the largest telecommunications companies in the world to understand and overcome the problems associated with contaminated connectors. In doing so, we've had the privilege of learning from some of the best process engineers in our industry. Along the way, we immersed ourselves in both the inspection and cleaning process, as well as the science that underlies how contamination can affect signal performance and connector longevity. Today, we use this experience to help optical equipment manufacturers, service providers, premises cabling companies, military organizations, and the aerospace industry. We develop application-specific hardware and training programs to implement a proactive inspection and cleaning program that can dramatically lower costs and improve yields.
Hello, I'm Craig Black with Westover Scientific. The purpose of this video is to pass along some of our experience with cleaning and inspecting fiber optic interconnects. Westover makes a comprehensive line of industry-leading inspection systems, and we also offer a line of precision cleaning systems for high-volume applications. Implementing a discipline for effective inspection and cleaning is more important than ever. Laser power, bit rates, and bandwidth have driven the requirements for cleaning to much higher levels. In order to provide some context to today's presentation, we'll need to review some fundamental aspects of fiber optic interconnects before moving on to inspection and cleaning. Let's start with the problem of dirt and the significant impact it has on our industry today.
You may be wondering why it is important to inspect before you connect. What is true of all optical interconnects is that contamination on the core will block light and reduce efficiency, thereby increasing insertion loss. Further, when that light is blocked, some light will be reflected back toward the source, increasing return loss or back reflection. In some cases, dirt near but not right on the core can lead to an air gap that will also introduce back reflection. Lastly, if the interconnect relies on physical contact, any dirt trapped between the two mated surfaces will damage the glass interface and can become embedded, requiring repolishing to repair it. To illustrate this point, consider this analogy. Imagine these drinking glasses represent the ends of a fiber connector. Now look what happens when these two glass surfaces come together with a pebble in between them. This is what is happening when you make two glass fibers together without first ensuring they are clean.
Today, contamination is the #1 problem in troubleshooting optical networks and equipment. The importance of inspection and cleaning is now commonly recognized across the industry, from Tier 1 manufacturers to the largest service providers in the world. However, while this information is widespread, most companies still inspect and clean only after a problem is found during system test or troubleshooting. We call this reactive inspection and cleaning because it's done after the connectors have already been mated. Tier 1 providers estimate that at least 40% of troubleshooting optical connectivity is simply a result of dirty connectors, making this one of the most costly problems associated with fiber deployment and major source of delay and downtime. A little dirt really can impact your bottom line. Today, the most progressive companies mandate proactive inspection and cleaning prior to mating the connectors. These companies have done so for two primary reasons. First, proactive inspection and cleaning is proven to drastically reduce troubleshooting time in manufacturing and field installation. Second, a proactive approach ensures that you're able to protect your company's assets by minimizing damage from mating dirty connectors. Beyond these tangible savings, perhaps the strongest motivation to inspect before you connect comes from the added ability to control manufacturing and make the deployment process more predictable. There are a number of actual cases where proactive inspection and cleaning would have saved companies considerable time, money, and resources. For instance, a Tier 1 service provider deployed fiber to the home and connected customers with voice and broadband internet. In doing so, the installer paid little attention to fiber cleanliness. The customers were initially pleased with the service until 2 months later, when video was switched on and the service would not turn up. In troubleshooting the problem, the provider had to go back and clean every connector between the customer and the central office. Once the last connector was clean, the system turned up without further effort. Had that provider proactively inspected and cleaned each connector during the initial installation, they could have avoided losing valuable time and money in deployment, troubleshooting, and dealing with unhappy customers.
To discuss an inspection and cleaning regimen in detail, we'll need at least a basic understanding of optical interconnects. Today, optical interconnects are most commonly found in two forms: physical contact fiber optic connectors and non-contact lens-based interconnects. Within these categories, there are a myriad of different designs and layouts. For the purposes of this video, we'll discuss three of the most common types: single fiber connectors, ribbon fiber connectors, and the lens elements commonly found in transceivers. You'll need a basic understanding of these structures in order to inspect and clean them properly. Simplex and ribbon connectors are typically physical contact connectors where one or more fiber optic cables are mounted within a ferrule, and that ferrule is mated against a matching ferrule with light spring pressure. This pressure holds the two fibers against one another to maximize efficiency of light transfer. Simplex connectors feature one fiber strand, typically in a round ceramic ferrule, while ribbon connectors utilize a rectangular ferrule with an array of multiple fibers. Both of these approaches require excellent alignment, positive physical contact, and a pristine end face condition to deliver a high-efficiency interconnect. In contrast, many transceivers today utilize a lens system to focus light into or out of an optical connector to couple light with an emitter or detector. There is no industry standard for how the lenses are arranged within these systems, and as a result, you will find different configurations in practical use. Generally, they employ a ferrule stop to locate the fiber in a known position, and lens element to focus the light from the fiber onto a detector or from an emitter onto the fiber. Some systems employ a flat lens that physically contacts the fiber as opposed to the ferrule stop. Now we'll demonstrate an actual cleaning and inspection process. Begin by identifying what connectors you are working with. With each connector, you'll need to inspect the male connector that is easily accessed, as well as the connector that is within the bulkhead adapter. That connector is often within a hardware device and can only be viewed through the bulkhead adapter. Attach your microscope to its display. You can refer to your operation manual for instructions. Here, we're working with an SC connector. To inspect the male connector, attach the appropriate tip to the probe, insert the connector into the tip, view the image on the display, and focus. Your company may have its own set of pass-fail criteria for determining whether the fiber is sufficiently clean. Alternatively, Westover can provide recommendations. There are some ongoing efforts in standardizing these criteria that may come to market relatively soon. In any case, if the fiber fails for contamination, clean the fiber and repeat the inspection. In general, you do not want to clean until you have first inspected. The cleaning process is not perfect and can actually introduce dirt onto a clean connector. The correct process is inspect, clean, inspect, and repeat if necessary. If the fiber is clean at any inspection, it is ready to be put into service. Remember, it is critical to inspect both sides of the interconnect before mating. To inspect the connector within a bulkhead, the process is similar. Change the tip on the probe to the appropriate bulkhead tip. Insert the tip into the bulkhead adapter and focus. Once again, determine whether the fiber is acceptable by comparing it to a set of pass-fail criteria. If the fiber fails due to contamination, clean the fiber and repeat the inspection. The process of cleaning through the bulkhead is a bit different, and there are a number of tools that can be used. We recommend using this type of cleaner or Westover's Clean Blast system, but traditional swabs can also be used. In any event, follow the manufacturer's instructions for use. Again, follow the process of inspect, clean, inspect, and repeat if necessary. If at any point the fiber passes an inspection, it is ready to be put into service. A couple of quick notes about cleaning. Dust caps are known sources for contributing dust onto a fiber. While this is not intuitive, it is a proven fact. Never assume a fiber is clean because you've just removed a dust cap. Also, you will run across fibers that have stubborn dirt that won't come clean. You can try using a wet-dry cleaning process on these. If you do, be sure to carefully follow the manufacturer's instructions, as wet cleaning processes can sometimes create more problems than they solve. Lastly, in some cases, stubborn dirt won't come clean, and the fiber must ultimately be rejected. Your company may have its own policy for how many cleaning cycles it recommends prior to rejecting a connector. If not, our recommendation is 3 to 5 cleaning cycles. If you have large defects or defects very near the core that won't come clean after 3 to 5 cycles, the connector may need to be repolished or removed from service and replaced. The last section we need to cover is inspecting SFP and XFP transceivers. These devices are becoming more and more common in our industry, and they provide some additional challenges. As referenced earlier, inside the transceiver you will find either a fiber stub or some sort of lens assembly. If you find a fiber stub, you can simply treat it as an LC connector within a bulkhead adapter. If you focus inside this device and see an unusual image that is clearly not a simple fiber end face, you are likely looking at a lens assembly of some sort. These devices vary widely in design, and it is not productive to try and teach you how to discern exactly what you're looking at in each case. What is critical to understand is that you're looking for contamination on an otherwise round field of light. Let's walk through some basic guidelines for inspecting transceivers. Begin by installing the FBPT LCL inspection tip on the probe and turn the focus control on the probe clockwise until it stops. Now insert the probe into the transceiver and begin turning the focus control counterclockwise until an image is in view and in focus. At this point, you will need to determine whether you see one of the following 3 images. If you see a fiber image with a distinct fiber core, then it is a fiber stub. This can simply be inspected and cleaned like an LC connector within a bulkhead adapter. If the contamination cannot be cleaned and the device does not perform properly, remove the device from service and replace. If you see an image with a distinct metal ring, then it is a ferrule stop. Once you have identified the ferrule stop, continue turning the focus control to see if any contamination is present on the lens element. If at any point you see a field of white light with dark specks, focus on the specks to view the contamination on the lens surface. If contamination exists, note that the lens element within this device is not accessible for cleaning. However, the device may still be operable. Furthermore, since it is a non-contact device, attaching a connector to the device does not risk damaging the connector or the device. Put the device into service. If it fails the inspections and does not perform properly, contamination is likely the root cause, and it should be removed from service and replaced. If there is no discernible fiber image or metal ring, then it is most likely a flat lens design. As you turn the focus control, you will see a variety of images at multiple focal points inside the device. If you see a field of white light with dark specks, it is likely the surface of the flat lens. If the contamination is on the leading surface of the lens, you should be able to clean it much like a connector within a bulkhead adapter. If the contamination is on a surface that is sealed inside the device, it cannot be cleaned. If the contamination cannot be cleaned and does not perform properly, remove the device from service and replace.
Inspection and cleaning are critical at every stage of handling fiber. Component manufacturing, assembly, system test, receiving QC, installation, and maintenance and troubleshooting. Many companies have already learned the hard way just how important this really is. For instance, if system manufacturer neglects to inspect and clean prior to mating fiber at system test, it's probable that a dirty test lead will contaminate and possibly damage the system before it ships. As you can imagine, this could cause all kinds of problems for the manufacturer and the customer. In summary, dirt and contamination are major obstacles to achieving a seamless, robust, high-powered fiber network. The tiniest particle of dirt in a fiber interconnect can have a huge impact on signal loss and the performance of your network. By proactively inspecting and cleaning connectors each time before they're mated, you will save countless hours and dollars on unnecessary troubleshooting and downtime. As the world's leading manufacturer of fiber optic inspection equipment, Westover Scientific offers a wide variety of solutions to match virtually any application where fiber is deployed. Our goal is to offer a simple, efficient, and cost-effective solution for maintaining cleanliness of fiber end faces at every stage of life. Thank you for your time. Remember, always inspect before you connect.
Westover Scientific, the industry's leading supplier of optical connector inspection equipment.